welcome back to another video. So in this video we are going to discuss about the policies now. So in the policies we do have a control policy and a data policy. Now control policy will be related to how you are affecting your fabric, and data policy or traffic policy is related to the manipulation of data path. And C flow, this is for the net flow traffic. So if you have any net flow in your topology, then you can create a policy to redirect all the packets or send a copy of packets to that particular net flow to examine or inspect. Now, both control policies and data policies are divided into two types, that is the centralized policy and the local policy. Now, the architecture of the policy, we do have a policy, and within that policy we do have a centralized policy and the local policy. Understanding the centralized policy. Now, centralized policy means affecting the network wide scope. So if this is my whole fabric now, alright, so this is my whole fabric where all the devices are connected. So if I create any policy, that policy will affect the fabric. So that is the centralized policy. But any policy that is a localized one, it will only affect the single device. So if I go back to my topology, so for example, if I created a localized policy and applied for branch 1, so branch 1 will only be affected, not all of them will be affected. The whole fabric will not be affected, only this particular branch will be affected. So that is a localized policy. And the centralized policy will affect the whole fabric, so you have to keep in mind. Now, centralized policies are further divided into the control policy and the data policy, as we said before. So now within the control policy, you have a control policy and the VPN policy. So within this control policy, you can create like blocking of the prefix, or if you like, you can create hub and spoke. So it's like more control. You have much more options to do whatever you like. So VPN membership we will discuss when it is when we are going to configure it. So traffic data. Now traffic data, again you do have like a capacity to control what traffic should be going in a which path, or if you want to allow or block a traffic or so and so. It's just like what do we say, if I, for example, if I take the hub and spoke one. So currently they are in a mesh topology now. So I don't want that one. So using the control policy, what you can say that branch 1, when communicating with branch 2, they should go via the data center. So it's just like a scenario where you are like trying to control your fabric and implementing some policies so that they act according to your instructions. Now similarly with the data traffic, now control policies, that's okay, it's only like affecting your routing table. Now data policy also, again you need to have it because you're defining a path how they should be going. Now for example, in a data center you do have an ASA like a firewall. You want, whenever the branch 1 wants to communicate with branch 2, you can say that go via the ASA also, like a service chaining which we discussed earlier. So it's like a data traffic is like affecting and manipulating the path of the data. Application aware routing, we will discuss this one in detail, don't worry about it. So currently for now, control policy, VPN and the traffic data, which we will focus on that one. Now localized policy, again you do have the localized policy. Within that localized policy, again you do have the traditional one and the security policy. Now localized policy, it's a route policy like a normal access list, or maybe a quality of service, or route policy means yeah, it should be access, but we do have a separate access control list over here, ACL. But again, route policy is also like accepting and rejecting the prefix and all those things. Security policy, this is where you will inspect the traffic using the firewall service, using the IPS service, using your URL filtering service, or advanced AMP, or the DNS like Cisco Umbrella. Now these security policies will only apply for a site because it will not be affected on the fabric wide. So this is my SD-WAN. So whenever you are implementing the security policy, it will only be applied to the device itself. It is like a localized policy, how we apply it to the device itself, the same way the security will be applied like an additional template. So as an additional template, you will apply only for this particular branch. So if you have a branch 2, I do have a branch 3. Now, branch 3 doesn't require any inspection. Branch 2 also doesn't require because there are not many people, but you do have many people connected on your corporate VLAN over here. And you want to inspect the traffic whenever it is going in or communicating with any of your critical application on your data center. So at that time, what you can do is that instead of installing an ASA over here and redirecting the traffic via that one, you can do it, and which is the preferred method. There is something called as a security policy where you will install a small application on the device itself that is called a UTD engine, Unified Threat Engine. So Unified Threat Defense Engine. So that small application will be installed on your device, and you, after installing that on your device, it will give you access to configure the firewall policy. Firewall policy, without that UTD engine, you can configure it. We will see it. But for the intrusion policy, URL, advanced, and DNS security, you do require this UTD engine. Alright, so that's all with the localized policy. Let's check about the policy domain, how things will be affected. So whenever we are talking about the centralized policy, so you see that the centralized policy means vSmart is the brain, so he is the one who is taking the decisions. So it is been analyzed, and it what you want the requirement you have sent it to vSmart, and vSmart is the one who is going to, I will say, implement that policy. So you can see that it is affecting each and every link which is connected to their devices. Alright, so you will create a centralized control policy, okay, that will be affecting your whole fabric, and vSmart is the one who is going to manipulate or implement that policy, what instructions you have given. Similarly, with the localized policy, you will create your local policy, but you will only be applying for a specific device, and that specific device can only, it's only affected, not the whole fabric. Alright, so localized policy. Again, you can use both of them together, centralized policy as well as the localized policy. So for example, here you see that the localized policy is applied over here, but the other device or other branch is been affected by the centralized policy. So domains, it can be anything, centralized or locally, you can use it both together also. Now, coming with the localized policy, mostly this will be used for the routing protocols. Okay, so for example, you do have like a BGP like a service connected or the OSPF, and if they are multiple path, like in our topology in a branch 2, we do have a device 1 and device 2, and we got connected our router with the OSPF, and now the OSPF have two default gateways. So we can utilize the localized policy, and we can create a policy in such a way that the router always takes the branch 1, not the branch 2, sorry, device 1, not the device 2. Currently it is taking the device 2 as per the normal behavior. It is electing device 2 as the highest router ID, and it is taking that path. So if you want, you can just manipulate, and you can say that always prefer this one, and if this one goes down, then prefer this one. You can create that one using the localized policy. And it can also happen with the same thing with the BGP also. You can utilize the different, what do we say, features or like metrics or different features in the BGP where you can manipulate the path using saying that again, okay, currently the BGP is taking device 2, you don't want to do it, so you just change the metric value, med value in the BGP, and you can just manipulate the path to take the device 1 instead of device 2. So it's mostly good for the routing protocol. Again, it depends upon the requirement. What are those according to the business, what do we say, requirements? You have to configure the localized policy. Now to create a policy, first thing is that there is something called as a list. So this list will consist of, like, you will be creating a building block. So what you required in order to have a whole picture of your centralized policy. So first thing will be like, if you have want to create any application list or any color list. For example, I want to create a color list of business internet, I can create, or the MPLS I can create. If it is any data prefix, it's this prefix is used for the control policy, and this prefix will be used for the data policy. And if you want to create the sites, yes, if so, for example, like I do have branch 1, I do have branch 2, branch 3, and branch 4. Now I will create a centralized policy which I say that I want to only get affected to branch 1 and 4. So you will create first what, site 1 and site 4, so that whenever the last part of the policy where you have to apply, you will say that on which bound, inbound or outbound, you have to apply those sites. Which site should be affected? That's what you are going to provide. Policy here, SLA, T-log, VPN, these all are the list of what do we say, features which we will be using to construct our centralized policy. So it's like a step-by-step construction. So when we create the policy, that's where you will understand what we are actually doing and why we need that. Next thing will be that what type of policy you want to create: control policy, VPN policy, centralized policy, application aware policy. Then you will utilize this list and you will call these features or the list over here in this particular policy. And finally you will apply. Now this is where it is very important. Whenever you're talking about the centralized policy, always look with the perspective of vSmart. By default behavior is that whenever there is a branch 1, branch 2, branch 3 and branch 4, by default they will send all the details, their route information, to vSmart, and vSmart will send back the details of other branches to their respective branches. So branch 1 will receive branch 2, 3, 4 prefixes via the vSmart. So vSmart is propagating, sending those details. So always when you are applying for the policy, when you are applying a policy, you have to be careful what information you want the vSmart to take in and what information you want the vSmart to give out. So you want to filter that policy. Using that policy, you want to filter that information inbound, or you want to filter that information outbound. Let's take an example first. So I do have a prefix of 10.10.201.1/32 over here. I do have one more prefix, 10.10.203.1/24. My requirement is that I want this prefix to be seen by branch 2, branch 3, but not branch 4. So in this case, I want to propagate the prefix to branch 2 and 3 but not 4, means I want vSmart to take in, that means accept that prefix, but while propagating, sending out, filter branch 4. Now this is one requirement. Another requirement is that I do have 10.10.203.1. I don't want any branch to see that one. So what I'm going to do, whenever the branch 3 sends that prefix to vSmart, vSmart will reject that prefix. So it will, in inbound, when it is receiving, it will just reject that prefix. That means it is not having any information. So when it does not have any information, it does not give out any information. Alright, so be careful in applying this one. So whenever you're applying the centralized policy, maximum time it will be outbound. Very rarely you will see that you need to apply it inbound until unless you don't want all the fabric to know about that particular information. Or if you're trying to intercommunicate like a VPN link, then only you will apply on the inbound. All right. So the process will be first we will be creating all the building blocks, that is the list which we require to create a policy. Then finally we will apply the policy for the branches using the vSmart view, whether it is an inbound or outbound. So that will become your vSmart centralized policy. Once your centralized policy is active, then you will activate that policy on the vSmart. And again, to happen this one, you have to make sure that vSmart is in vManage mode, not in CLI mode. So if vManage is controlling vSmart, then it is able to push the policy, otherwise it is not able to push. Now packet forwarding order of the operation. So first when the packet comes in, it will try to look up for the as usual like a normal thing. Next it will check if it has any local ingress policy which is applied inbound. And again it will check for the app route centralized policy, SLA path based. So if there is any critical application where you have defined the SLA, it will check that one. And after that, if there are no SLAs, then it will go ahead with the remaining quality of service and what do we say, remaining policies, control policies, data policies, all the remaining policies. And finally, it will check if it is a control topology driven forwarding or not, like a control policy or data policy, routing and forwarding things. And find after that on this, it will also check for any security point. So the packet is coming at branch 1. This is my LAN trying to communicate with the branch 2. When the packet is being received on the egress port, that is gig 0/2, the router will definitely look out for the destination prefix, that is 10.10.202.1/32, and it will also look for the local policy if you have applied any. Next it will look for the SLA if there is any SLA or application critical info traffic defect detected or not. If nothing, then it will go with the policy, then it will analyze that policy. Finally, it will check for the security policy. After that, again, it will check if there is no inbound local policy, if there is any outbound local policy or not. That is your egress. So the interface which is leaving that traffic is leaving that interface, that is known as a egress. And finally, if we'll check for any policies which we have to manipulate, like packet renaming or editing some details on the packet or not. Like for BJP, if you have manipulate the MET value, then it will just inspect that packet and it will change the MET value and start propagating on that one. So this is how the packet will flow. Now let's look into the scenarios. We will start up with our control policy. So until now, I hope the construction and architecture of the policies was clear and good. I hope this was informative for you, and thank you.